Alright guys, in this video we're going to look at motion diagrams. So what a motion diagram is basically this representation of motion, and it's as if we were taking a bunch of photographs of an object in motion, but we're taking those photographs at equally spaced time intervals. So there's a couple important thoughts here, is that when we're looking at the object's motion, we're really looking at its position. All right, so if we look at the example down here of this bottom motion diagram, this is of a person running, right? So we're looking at this person's position over the course of time, and each of these pictures represents an equal time interval. So from picture 1 to picture 2, that was, let's say, a picture is taken every 2 seconds. So this means 2 seconds passes from here to here. And then from here to here, another 2 seconds will pass, and then from here to here another 2 seconds will pass, and from here to here another 2 seconds will pass. So when we're looking at this, we can see that the person hasn't done the same thing over each time interval of 2 seconds, right? The distance that they covered from here to here was a lot larger than the distance that they covered from here to here. All right, so in the same amount of time, now they're covering a greater distance. So that's the first thing, is that we're looking at the person's or the object's position, and again we looked at the equally spaced time intervals. So that's basically how we're going to represent motion using these motion diagrams. All right, so what we can tell then is here, if we're looking at a span of 2 seconds and they only went about, let's say, 8 meters here, because we have the meters marked down on the bottom here, right? So let's say that from start to the first 2 seconds they covered about 8 meters. And then if we look down here at the second situation that we were looking at, is they went from about 32 to 50. So let's say they went 18 meters during this time interval, right? So what that tells us is if there's a greater amount of space between the two pictures, that tells us that the object was going at a higher speed or a higher velocity, whereas when there's a shorter distance between the two pictures, that tells us that it was a lower velocity. And right, if the object wasn't moving at all, then we would see two pictures directly on top of each other, right? And that would tell us that there's no motion happening, right? So the further spaced apart the pictures are of the object or of the person, the greater the velocity was. And we can tell that because in the same amount of time they covered a greater distance, and that's the definition of a higher speed or higher velocity, right? So the more spaced out the pictures are, the greater the velocity. That's a very important concept to know for these motion diagrams. All right, so if we, let's say, look at these two diagrams compared to each other, we have this diagram here. Every second there's a new dot, so every 2 dots is 2 seconds as they labeled here. So we went the same distance every time, right? We covered, this one is in feet, so we covered 2 feet for each dot, from 2 to 4, from 4 to 6, 6 to 8, 8 to 10, 10 to 12, and 12 to 14, right? We're covering 2 feet every time, and each of these dots represents 1 second, right? So this means that there's a constant velocity. So if you see the spacing between the dots stay constant the whole time, then that tells you that the velocity is constant. Whereas in this bottom diagram, we've already seen that the velocity actually changes, right? So if we look here, we went a distance from, let's say, every 2 seconds, like we were saying. So we went a certain distance, then we went a slightly greater distance, slightly greater distance, and a slightly greater distance from here to here, right? So the difference between these two motion diagrams is this one, the dots stay equally spaced the entire time, right? And that tells us that there was a constant velocity. But here we started from rest and then increased our velocity over time because the spacing is slowly increasing as we look at each next time interval, right? So if the spacing is getting bigger, that tells us that the object was speeding up because, again, the bigger the spacing, the higher the velocity. So this tells us that the object is speeding up. If we saw the dots getting closer together, then that would tell us that the object was slowing down. All right, so if we look at 4 motion diagrams here, I want you to try and indicate in your notes what you think is happening during each of these motion diagrams. So assume the same thing where we're taking equally spaced pictures in terms of time. So try and identify what A, B, C, and D, how you would describe that motion in words based on this motion diagram. Okay, so for motion diagram A, if we look at this person here, there's only one picture, right? This really would be probably a whole bunch of pictures overlapping each other. There's no motion here because every frame is staying in the same position. So if there's no change in position, then there's no motion. So this would be an example of no motion. All right, and in picture B here, we're looking at this person moving, and if we look at the spacing between each of these frames, it's staying the same the whole time. So that tells us that this person would be moving with a constant velocity or a constant speed because the pictures were staying equally spaced the whole time. If we look at picture C, we have a little bit of motion here from frame 1 to 2, a little bit more from frame 2 to 3, a little bit more from frame 3 to 4, and then more from frame 4 to frame 5. So what this tells us is that this is an increasing velocity because the pictures are getting more spaced out over time, right? They started with a little bit of spacing in here and then more and more and more as we go on. So that tells us that there's an increasing velocity based on this motion. And then if we look at picture D, we have a big space here, slightly less spacing here, less spacing and less spacing. So because the velocity is decreasing over time here, because the spacing is decreasing over time, then we can tell that the velocity is decreasing over time. So this would be a decreasing velocity because the spacing is getting smaller and smaller each time. All right, and the last thing that we need to be able to do is construct motion diagrams based on a situation. So we've done describing motion diagrams using words. Now we're going to try and translate words into actual motion diagrams. So this example here, draw a motion diagram of an object that's moving at a constant speed and then slows down to a stop. So we want to think about what these terms would look like in a motion diagram. So constant speed, what we said is that the dots are going to be equally spaced during that time period, right? If it's a constant speed, then from the first dot to the second dot to the third dot is going to be all the same spacing, all right? So this would indicate a constant speed. And then it slows down to a stop. So in order to translate this slowing down into pictures in the motion diagram, we're looking to have the dots get closer together because slowing down means closer together. So we would then draw a little dot like this, and then maybe the next one would be here, and then the next one would be here, and here. And so then we just draw the dots getting closer and closer together. So here's the part where we did a constant velocity, and then because the spacing becomes less and less as we go there, now we know that this is a decreasing velocity and slows down to a stop. Ultimately, we would draw another picture on top of the last one to show that it actually came to a stop. But that can actually be difficult to draw. So when you're drawing these motion diagrams, you just want to think of the opposite of what we did when we're interpreting the motion diagrams, is we're seeing what does it mean when we have pictures that are equally spaced versus pictures that are growing further apart versus pictures that are getting closer together. All right, so that's how we can tell about the velocity of the object, is how the spacing of the objects and the pictures maintains. So here, same thing, we were looking at some equally spaced objects for the constant velocity, and then we made them closer together and closer together to show that they were slowing down to a stop. All right, so try and work on constructing some of these motion diagrams using the rest of your worksheet, and we'll go over these when you guys are done. Thanks, bye.